All right, hello once again. This is Jeff Scott of Rankin Technical College. And for the Rankin Technical College Application and Website Development, or AWD1100 Programming Fundamentals with C# course, I've been creating a series of videos that are based on the PowerPoints for the textbook we're using for the class, which is Muroc C# 7th edition. And I did a little bit of out of order in that I had already done the first 6 chapters. But then, rather than going on to 7, I went and did Chapter 11 on how to debug. But I'm back now, and I'm going to do Chapter 7, how to handle exceptions and validate data. So that's the idea behind what we're going to be going through right now. Chapter 7. Now, at the end of the chapter, they have you work with the calculator program. So I have that up. I've made a copy of the original, and I'm going to modify the original to make it look pretty much the way that they show at the end of the chapter here. So with that said, let's just get started. As always, we have our cover slide here. So Chapter 7 is on how to handle exceptions and validate data. As always, we have our applied and our knowledge objectives. All right. Notice in our applied, given a form with text boxes, write code that catches any exceptions that might occur. Given a form with text boxes, write code that validates user entries. And use dialog boxes as needed within your application. Those are our applied. Our knowledge, be able to understand what exceptions are, including the exception hierarchy, how to use try-catch. There's also a finally word that can be used in there. Describe the properties and methods of the exception object, be able to throw a statement or statements, describe the types of data validation you're most likely to perform, describe 2 ways you can use generic validation methods, and those will become very important, but I'm going to go over those more so in class than I will in the description here. All right. Now, if you remember, if you watch these out of order, and you did watch the one for Chapter 11, and let's assume you did not, I've mentioned that there are basically 3 ways, in my humble opinion, to handle errors in a C# program. The first is what I call either the ostrich method or the duck and cover method. And what I mean is you don't put any error handling into your program whatsoever. You just hope, take for granted, whatever, you assume, all right, that the person running the program will never put in bad data. Well, you know what happens when you assume, as the saying goes. So that's the worst way. The way we've been handling, not errors, but whatever we'll call invalid data in the past, through the first 6 chapters, what we built into is we don't let bad data into the system at all. We use if statements, etc., that check the data, and if there are errors, we just don't let them go through. Well, the other way is what this chapter is about, and that's handling exceptions using exception handlers, and in particular using a try-catch block. So we're going to see that in this chapter. Now, it says the exception hierarchy for 5 common exceptions. The key thing to note here is all of these are children, grandchildren, great-grandchildren, whatever, of the exception class. So the most generic type of exception that you can throw is exception. All right. So if you go, you can catch multiple exceptions. This one must always come last. If you put the exception first, you never get to the children below or grandchildren or whatever. In the same way, a divide by 0 exception is a type of arithmetic exception. So if I'm going to put in all of these exceptions here, the way that I'm going to do it is I'm going to first list these 2, then these 2, then this one last. Now, going back to our old friend here that we have seen before on several occasions, that being docs.microsoft.com, I'm going to type in here C# exception. I don't know if there's an exception class. Yeah, it looks like it. Okay. Exception, C# language specification. Well, I'm going to grab this one. I don't know if it's the one I want. And it's a bunch of articles. There we go. Common exception classes. So these are things that can happen. Notice they're all system exceptions. Arithmetic exception. Divide by zero exception. When we get into the next chapter and we talk about arrays, index out of range exception. Invalid cast exception. And there's more. These are some of the more popular ones. I don't know exactly how many there are. I'd have to really dig through the documentation. But I know that in many programming languages, there are upwards of 100 different exceptions that literally can be thrown in a program. These are ways that you could throw an exception. So if you try to do a convert, you've seen these already. We try to do a convert to one of these, decimal, in32, double, or whatever. And what we put in here is not a number or not a string representing a number. You can get a format or an overflow exception. When you try to do a parsing, you can get a format or an overflow exception. Date time we're going to cover in a later chapter. All right. So here's one way of handling it. Using a message box, kind of what we've already done when you think about it. We used an if statement, and if something went wrong, that's what happened. We brought up a message in a message box, an error that said something was wrong. I mean, again, look at this. Here's our simple, let's see, cannot be open. No. Let's go to open a project or solution because I renamed this one. And I called it Simple Calculator with Exceptions. I renamed the folder that holds it. Now, what I was getting to, though, before I so rudely interrupted myself, was we've done this. So in other words, remember that if this was empty, we called show message, and what did show message do? It provided that message and that title, and that was down here at the bottom in here. They're having you talking about doing something similar right here. So nothing new there, nothing we haven't really looked at already. All right. But there is more to exception handling than that. Another way of doing this is to, they do a very good job of showing it here. And that is using a try-catch statement. Now, I don't like the way they did this, but it's fine. What you put in the try block, the reason I call it a try block is that all the try statements between the curly braces. So try, curly brace, curly brace. So the try block is everything in here, and the catch block is everything in here. What you put in the try block is code that could potentially fail. And if it fails, the catch is what you do in there. Now, this is a simple example they put in there, and I don't know why they showed it like this, but they did. You virtually never see it, in my humble opinion, done like this. But what you will see in just a couple minutes is the way that pretty much it's done and the way we will do it. Now, exceptions have properties associated with them, and in particular, a message property that describes what the exception is, and a stack trace, and we've seen stack trace before. All right, where it lists the methods called before the exception occurred. There's also a get type, which shows you the type of the exception. Now, this is a little bit more similar to the way that you'd use exceptions. So this says, in the try block, we are attempting to convert whatever is in the text box named txt subtotal.txt to a decimal, and if we can convert it, we put it into a variable, a decimal variable called subtotal. If for some reason an exception is thrown because we left it blank or put it non-numeric or whatever, we put in a message box. All right. Now, they're printing out everything here, the message, the type, and the stack trace. So the message is this. The type is this, and the stack trace is in here. So here's the syntax. You can catch as many errors as you want, but again, they have to go from most specific to least specific. If all the statements in the try work, you totally skip the catch. If anything in the try fails, the system goes in and looks for a matching catch statement. The finally is typically used for housekeeping operations. And the finally runs whether the try worked and you skipped the catch, or the try failed and you did a catch. So it's typically done for housekeeping operations. If you've got a database open, it closes it. If you've got a file open, it closes it, etc. So this is a lot more realistic or reminiscent type of thing. So this says try to do this stuff. If you get a format exception, do this. You can only one of these exceptions code can run. And it looks for the first one that matches. So if something fails here and it's a format exception, it does this, skips all this, and goes down to the finally. If you try this and it fails and it's not a format exception, but it's an overflow exception, it does this, it skips this, and it does the finally. If you try doing it and it fails, and it's not a format and it's not an overflow, this is kind of like putting in a final else when you've got an if with a bunch of else ifs. So this says, hey, if you can't catch anything else, catch it here. If everything succeeds, you skip all the catches, but you still do the finally. I'm trying to crystallize this for you and make it easier for you to understand. I think that once we see this in class and we go through some examples, if it doesn't make sense now, hopefully it'll make more sense then. You can throw your own exceptions. Either your own exceptions or system exceptions. All right. When to throw an exception? When a method encounters a situation where it's not able to complete its task, rather than having the program blow up. When you want to generate an exception because you want to test to make sure that your handler works. When you want to catch the exception, perform some processing, then see if if the processing you did worked or didn't work. So here's examples of throwing exceptions. Now, this is the example that I typically use. There's nothing wrong at all with what the example that they show here. But imagine we're writing a very simple program that's supposed to do miles per gallon. All right. And we input the number of miles somebody drove, and we input the number of gallons that somebody used in their gas tank. Well, let's say that the most number of gallons that you can go on a gas tank is, I'm going to make this up, 500 miles. And let's assume that the amount of gas that you put in has to be up to, but not over 15 gallons. Well, if you put in a number of miles driven greater than 500 or less than 0, or a number of gallons greater than 15 or less than 0, there's no built-in C# exception that's called a miles per gallon exception, but you can throw your own and handle it and have it do whatever it is you want to or need to do. All right? And that's what they're talking about here. All right. Code that uses a throw expression to throw an exception. Well, notice in here, this is working with the null type of thing. Again, product code can have nulls. So this says the code, set the product code, assign that to the code. If there is no product code, you can throw a new exception that says it cannot be null. So again, this is a fairly new invention or whatever you want to call it. All right. This is the future value thing that they've been going through in the book. And they've got some code in here. But notice, this is the try block. So potentially any line of code that's in this try block could fail. If any of those lines of code do fail, you start to look for the matching exception. Again, from most specific to least specific. If I put this code here for the catch exception X at the top, these would never get hit because every exception is a type of exception. All right. And how you handle that, again, is up to you. Okay, so now what they're doing is they're showing you some places where you might want to do this. So notice, this is the kind of thing we did before. We said if the investment is empty, have a message box. Now this right here, this is not throwing anything. This is the kind of thing that we did before. Here's other things where we're checking. Notice this decimal parse. If it didn't work, we're doing a thing that says that it was invalid. We did something not exactly this syntax, but similar to this. Here are range checks. We've done that. If you remember, when we looked at a grade and we said the grade had to be between 0 and 100. So there's all sorts of checks that go on in a program. Here's an example of a field that's required, and you check whether or not it's present. Now, I do want to mention some of these because in the textbook, they will talk about this is present. They will talk about an is decimal, and you could change this and have an is decimal, an is int, an is double, etc. And they have a range check in here. So we are going to be looking at programs in class that are going to go through those in much more depth and breadth of coverage. All right. Here's a dialog, as it says, that displays 3 different errors. All right. It's all coming from basically the same catch, but it's totally fine to do that. All right. So here, as it says, they're validating multiple entries. And how are they doing that? They are calling this routine, this routine, this routine. And again, notice that none of the stuff that's in here, none of the stuff right now in these examples in the last few slides are working with try-catch. As I mentioned, there are different ways that you can validate. Now here's an example, as they say, of invalid fields. So notice you get multiple errors. Here's the dialog box for something that you didn't plan for. Notice the difference between these. Here it's an exception that you handled. Here it's an exception that the system handled. And I believe what the author is trying to show here is that when you let the system handle it, it's much more terse. It's harder to read. It's harder to understand. Whereas when it's customized by the user, it can be much more friendly, much more descriptive. All right, so here's the code for the future value app with a try-catch. And I'm not going to say anything more about it. Now, I think my boss is about to come in here. So this is what I'm going to do in the next lecture. I'm going to go back to our simple calculator, and I'm going to add exception handling that's going to handle this and this. All right? And I'll come back with that in just a couple moments. All right, I'm going to continue then, and what I'm going to do is basically attempt to do what's shown here in 7.1 and 7.2. Now, mine doesn't look exactly like this, but it's very similar. So what I want to do is if we put a 0 in there, I'm going to actually very simply, all right, just kind of modify the code that I have in there to throw a divide by 0 exception. All right, and if you say I don't know what you mean, then just watch if you would, and I think that you'll hopefully start to get it. All right, and I'm going to take a picture of this. Because this is what I'll want to have happen right here. I'm going to use their verbiage and everything else. So file new, no, yes, boom. So I'm going to do that if you attempt to divide by 0. Also, for the other one, if take a picture of that one as well. If you put in a symbol that is an invalid symbol, in other words, this is not a plus, minus, etc. Right now I'm handling it with a simple if, but I'll throw something else in there. All right, so these will be the 2 errors that I will be attempting to solve in a different way than they're being solved right now. And again, I want to reiterate to you that what I'm doing here right now, there is literally nothing wrong with the way that it is currently being done. I just want to show you another way that it can be done. So let's get into the code and let's get into those divide by zeros. So here, it's if it equals 0, see what we're doing? All right, so I'm going to comment this out. All right, and I'm going to totally comment this out, and I'm going to totally comment out this one. Now, it'll give me errors, and the reason it's giving me errors is because I'm supposed to return a double, and now I'm not returning anything. So I'm going to get an error here and an error here. We'll fix those. But I want to keep the existing code in there so you can see. So I'm going to put in here a try block. All right. And in my try block, I'm going to say, let's see. Yeah, we'll say return n1 divided by n2. Now again, that can conceivably fail. And it can fail. In fact, let's do it like this, because I think I can come up with a way where I can use the finally block as well. So again, I'll put in double result equals 0. And here I'm just going to say result equals n1 divided by n2. All right. So that's my try. Now I'm getting errors. Whoops. I'm getting an error here because there's no catch. So I'm going to catch here, and I'm going to attempt to catch. I don't want to just put exception in here. I'm going to catch a divide by 0 exception. Now, you can give these names. So I always say divide by 0 exception. I give them basically the wordage that's in here. You don't have to do that, of course. So I've got this, and now I'm going to catch. All right, so this is what we want to have happen. This is what we want to have happen if you illegally attempt to divide by 0. All right, well, the first thing I'm going to do is I'm going to just accept what's in there. I'm going to say that the result is 0. But before I do that, I'm going to come in here and I'm going to do a different message box. I think we've got our show message thing in here, right? Good. So we've got our show message. So let's put that in there. So I'm going to do a show message, but I'm going to do it a little bit differently here. The first thing I'm going to do is I'm going to put in dbze dot, is it just message? Message. So this is the system message that we're going to get. All right. I'm not even sure what it'll say. We'll find it out in a minute. All right. And I'm going to add to this a \n. Okay. And I'm just going to put in here illegal attempt to divide by 0. Pretty much what it is, right? And then we have to add to that, if you remember, we need our title for a show message. And so we'll put illegal attempt to divide by 0. The same thing. I mean, normally I wouldn't put the exact thing. Let's just put in illegal divide by 0. So we've got that, and we shouldn't get an error when we do this. There. Now, I can put a finally in here also. So I'm going to put in a finally, and remember, this runs whether the try succeeds and we don't do the catch, or the try fails and we do the catch. So either way, I'm going to return the result. All right. Now, double. Why doesn't it like this? So return. Control cannot leave the body in a finally clause. Okay, I mean, this is not how finally is meant to be used, but I'll tell you what, I'll put this down on the bottom. And what I'll put then in the finally clause, just so we've got something in there, is I'll put down, I'm going to put in another show message. And I'll just have it say, in proof finally block entered. All right, and we'll put in here for our title, finally block. Now, you wouldn't typically do this, but I'm doing this because I'm about to run the program. And when I run the program, what I'm going to do is I'm going to show that the finally is going to get hit regardless of whether the try succeeds and there's no catch, or the try fails and the catch runs. Now it's saying here, not all paths return a value. Now that's the modulo one. So let me just for now, I'm just going to, I'll put in here return 0. This is on the other one. I want to see if this works. And if it does, we'll put something similar into the other one. So let's go back and look at this again and run through the whole thing. So now when I use divide for my operation, I'm going to attempt to divide n1 by n2. But remember, it is possible and plausible that I put a 0 in for n2. If I put a 0 in for the second number, now it should come in here and it should show a system error message, plus it should show illegal attempt to divide by 0. This should be, that right there should be the title. I'm setting result equal to 0. Okay. And regardless of whether this succeeds and I don't do this, or this fails and I do this, it should come in and do this. Let's see if indeed what I just said to you is correct. So I'll run the program, and I've got to put a 0 in for my second number, and it's got to be a divide. So I'm putting in a 0. So now all it's saying here is proof the finally block was entered. All right, I thought it would do more than that, but let's take a look. All right, and it still did this. I don't like that. So let's look and see if we can figure out what happened here. All right, so in other words, it said that this was valid for doing it. All right, so in other words, what it's saying there is it is legal to divide by 0, but it gives you infinity. So what I'm going to do here is I'm going to do this. I'm going to say if n2 equals 0, I'm going to tell it to come in and throw a new divide by 0 exception. Like that. All right. Otherwise, it should just do this. So now I'm forcing this here to happen if I put in a 0. All right, so let's see how that works. Now, attempt to divide, that's the system error, and a legal attempt to divide by 0, that's what I put in. That's the title I put in. Now, when I click OK, it should say finally block entered. All right, so you see that, and now it gave a 0 here. If I do it the other way, so if I clear this, all right, and I click calculate, notice all I get now is proof that the finally block was entered, and there's my answer. So it did work. All right, so I'm going to exit, and yes. Now what I'm going to do is I'm going to grab everything that's in here, everything, from top to bottom, all right, other than what I commented out, all this stuff that's in here. I'm going to copy it to the clipboard, and I'm going to paste it right in here, because there's only one thing I have to change, and that is I have to make this a modulus. It's still a divide by 0, so now I'm going to say illegal attempt to modulo, just because I like to give the user an idea of what went wrong as much as possible. All right, so let's run this again. You've already been shown that the first one worked. So I'll just put in a number, but now instead of divide, in fact, let's run it again and put a divide by 0. And you saw, all right, attempt to divide by 0, illegal divide by 0, boom, there's our finally block being entered, and there's our answer. But I'm going to run it again, and instead of 77 divided by 0, I'm going to do a 77 modulo 0. I should get the other message now, all right? So illegal modulo by 0. Now I should change this, but that's what the system puts in. I can't change it. Attempt to divide by 0, illegal attempt to modulo by 0. I still get my proof that the finally occurred, and it gives me a 0 there. So that part works. So part 1 of this works. All right. So let's look at the other part. So we've got this working right now. It says unreachable code detected right here. Return 0. I don't need that anymore. I'm returning the results, so I can get rid of that. Oh, I put that in there before just so the program wouldn't blow up. So that's now fixed. So in other words, what we've done so far is we've come in here and we've done this part. I guess I didn't put exactly what they had. Divide by 0 error. Please enter a non-zero. But I can put that in. I can change it to that. I mean, I don't think it's a big thing one way or the other. All right. So here we've got operator is not valid. Now, if you remember when we did that, all right, that is in, it's up a ways. That's that big there. Nope. That's this. So right now, if it's not one of these, we're doing a show message. All right. Now, what we can do instead of this, all right, let's see, checking for a valid operator. I mean, there's different ways that we can do this. Again, what I'm planning on doing is I don't like to remove the workable code in here. So I'm going to grab everything that does work and comment it out. And there's maybe the way I'm going to do this is a little cheesy. But I don't want to waste too much time on this. I'd rather go on and continue on with what we're doing. So I'm going to say if it's not one of these, I'm going to tell it to throw a new format exception. All right. So that's all I'm telling it in there is to do that. And then what I'm going to do is, let's see. This is not in a try block. I don't know why it couldn't be. So I'm going to try to put all of this in here. Like that. All right. And then I'm going to catch the format exception, which again, I will call that FE for format exception. You can call it anything you want. A lot of times people call it E or EX or whatever. It really and truly does not matter. All right, so I'm going to change this around a little bit. So let's see. I'm going to grab the code this is the code that's in there currently. So let's see what I want to keep, if anything or everything, and what I don't want to keep. So I'm going to call show message, and I'm going to change this. So again, I'm going to put in fe.message, and that will give me the system message, plus, and in here, I'm going to put in \n, and I'm just going to change this to, I'll put in here, illegal operator entered with a \n and a plus, and I'll add this. As it says, operator must be one of these. Okay? And here I'm going to say, instead of invalid operator, probably should have done this on the other one too. I'm going to put in here format exception thrown. There we go. All right. I can still do all this. I still got my return red file. It should still work. We'll find out. So file, save all. Let's run this. So I'll put in a number and this, and I'm going to leave that blank. Format exception thrown. One of the identified items was in an invalid format. That's the system error. Illegal operation entered. It must be one of these. That's what I entered. Put that in there, and notice the program still works. So what I have just demonstrated to you is that I can basically run this program and I can make sure that it has what it's supposed to have in here, all right, using either exception handling, using the try catch, and I even added the finally. I guess I didn't have the finally in here. I could have put it in anyway. Let's put it in just to be sure. So I can do it either using exception handling or non-exception handling. So let's grab that finally that we had from over here, because I don't feel like... All right, and let me change these as well. So this divide by 0 exception, I'm going to change this to divide by 0 exception thrown. All right, I like that better. And let me come back up here. And we will add, like I said, the finally block right there. So I'll say here, finally block is valid operator. I'm just letting the system know where I threw that. Again, I believe you can't give too much information when you're doing this. And this is in divide the operands. And I also had that in here. So I'm going to change this to divide by 0 exception thrown. Whoops. And I'm going to have this say finally block and divide the operands. Now, what did I just do? I want to show you. So I'm going to come in here. Let's put in a 0 here. Now notice finally block, and I'm letting you know where it happened and that it was entered. Boom. Illegal attempt to divide by 0. Proof that it was entered. Boom. All right. And the same thing should happen when I do the modulo. I mean, there's a lot of stuff that's going on in here, as you can see. I don't know why it's entering that twice. I'd have to go back and take a look. It's not really that important. All right, I'm going to clear it and do one more time. When I put in an invalid symbol, and there's my other one, format exception thrown, with the finally block in the is valid operator. Okay, so that pretty much is what I wanted to show you in here. Now, so I'm going to do a file, save all here, and I'm going to shut this down for now. But what I want to mention to you, because I'm done now with Chapter 7, is next I'm going to go over Chapter 8. The reason I'm taking a second to mention this to you, this, in my humble opinion, so far from the first chapters 1 to 7 and 11, this is the most comprehensive chapter that we've looked at. And there's things in here we have not discussed yet. I am going to spend most of this lecture on arrays, which are a type of collection, but I'm not going to delve real deeply in this lecture on this next lecture on collections, just so you're aware of that. I'll be back with that shortly.